holds a PhD in computer science from the University of Kaiserslautern in Germany. Anne?
Thank you. All right, let's start with this one. All right, thank you for the introduction. So I'm going to be talking about visualization primarily with a focus on shopping district visualization. I'm going to start with a quick project overview, talk about the data sources, and then show you a whole bunch of visualizations. So as a project overview, this is part of a regional mobility project where we're trying to build a digital twin of the Chattanooga Metropolitan Area and then build a situational awareness tool to really explore what's happening with the data. Currently, we're in that orange cog phase of mostly just visualizing what we have in terms of data and understanding the data that we get. But long term, we're going to implement traffic control methods, and we're also going to work on predicting traffic changes. I'm not sure what changed here. I'm just going to skip ahead to the next one. So I'm going to show you a couple of screenshots of a very early prototype of the tool that we're working on. It's much further along right now, but we're kind of working on releasing our first release, and there was not a good time of, oh, now I'm going to take all the screenshots. It's like, well, if I wait for another day, there's going to be more stuff. So that didn't happen, but I'm going to show you anyway. So this is basically our landing page. So on the top left, you see a visualization of region-level radar data from all the local highways. So blue has your volumes, and then in red you have mean speeds, and then the 5th and 95th percentile as a gray band. On the map, you see live ways data. So those are all the incidents that are currently reported. That white box now has 911 incidents as well as Waze incidents in it. System news is what the label says, and at the bottom you see a meteogram, so you can't see quite all of it, but basically gives you a little bit of forecast for the next 48 hours of what weather's going to be like, because that may or may not have an impact on traffic. Then we have a map. This is just a view of all the sensors that we have. The green ones, well, I'll show you later. I have another slide that has more of the separate sensors on it, but on mouse over, most of those sensors now also display a little chart or maybe a live view of a camera, depending on what kind of sensor it is. That was not the case when I took the screenshot, so it's not on there. And we have a corridors tab, which looks much more fancy now. So we have a couple of different corridors that we've defined in Chattanooga. And then there's a corridor level visualization. There's a much nicer one on a later slide. And then if you expand, you get detailed information about all the intersections and all the radar sensors that are on that corridor within the polygon that's been defined. So it's just all done through a polygon. Then we have a metrics tab in which we have fuel economy metrics. We have some safety metrics in there. There's also an incidents tab, which has some amount of overlap, but I don't believe I have a screenshot. I do have the charts, though, later on, so you're going to get to see those. So to just give you a little bit of an overview of the data that we have a little over 100 different data sources now. The ones in this diagram are just a subset of those, but basically we have a bunch of traffic data ranging from radar data on the highways. It gives us lane level information at certain intervals. We have sensors on intersections that give us real-time and historic data. We have some data sources where we only have historic data, sometimes from the previous year or from the previous quarter. Some data we only get in real time, and if we want to store it, we need to make that happen ourselves. So there's a big disparity of different types of data at different frequencies that we're kind of trying to deal with. The colors here are kind of like a traffic light scheme, so the red means we don't have it, yellow means we have some of it. For example, maybe we have historic data, but not real-time data for something that we need real-time for. Green is we have the full thing, and if it's highly saturated, it means it's very important to the project. Less saturated means it doesn't really matter that much. We can make do with other sources. So let's talk about the two types of sensors that most of what I'm going to present today is based on. So first of all, the city of Chattanooga has 71 GridSmart cameras. So basically those are fisheye cameras that sit on top of an intersection, and then the sensor itself, or like the product itself, does a lot of computer vision based processing, and then gives us timestamps, speed, length of the vehicle, approach direction and turn direction for each vehicle that passes through the intersection. And you can get them in real time, or you can get a historic, and the formats are completely different. One gives you CSV files, the other one gives you JSON files. So if you know what those are, you know that they look pretty different. So that's fun. But yeah, so currently we have access to about 30 of those. The rest are not fully connected yet, but we do have a whole bunch of them on this corridor right here. So I'm going to be talking about that a little bit more. So that's Shallowford Road. It's a major shopping district. There's a lot of shopping in that area. But then we also have more sensors. So first of all, we don't have sensors on all traffic lights, and we're going to work with the controllers directly for the other traffic lights that don't have GridSmart. But we also have those radar detection sensors, and those are placed about every half mile or so along the major populated areas of the highways in Tennessee. So there are 4 regions. Chattanooga is in region 2. Each green dot here is, I think, actually one sensor in each side of the road, or it might just be the different sensors. Some span both sides of the highway and some don't. So that's also interesting to look at. Yeah, so those give us 30-second aggregates of vehicle counts, occupancy, and speeds for each lane of the highway at that particular spot. It's also supposed to give us vehicle class, but that column, or all those columns, are 0 most of the time, so that's not been that useful. So we're hoping to have them fix that. Also, side note, so there's a big space with no sensors, and there are more sensors up there. That's a major fog zone. There was a big crash there in the 90s due to fogs. So they have a bunch more sensors there, although there are not that many people living up there. So let's look at visualization. So as I said, we're going to be looking mostly at Shallowford Road and that general area. And if you look at the map, there are 2 major malls, and then there's a lot of shopping. There are a whole bunch of hotels and restaurants. There are also some on the other side of the highway. And then, I don't know if you can see my mouse. There's a road that runs kind of, not quite parallel. It intersects a little further north. That's Lee Highway. That also has a lot of traffic, so a lot of traffic comes from there. I think I can figure out which one that is. I think this intersection here is the right one. So a lot of traffic comes from there onto Shallowford Corridor as well. We're going to be looking at 2 roads for GridSmart. So we have Shallowford Road, which they call it west to east. It's not really quite west to east, so it's close enough. And then there's Gumborough Road, which intersects Shallowford Road to lead down to those big shopping malls. And they also have a bunch of GridSmart sensors on there. But then we also have those a little bit of highway data that is relevant. So along this highway, this is I-75. So up north, you go to Knoxville. South, you go to either merging on 24 West to Chattanooga, or you stay on I-75 and you get to Atlanta. And then we get a bunch of sensor data along here. There's one exit that is actually specifically for one of the malls here. So that also has an impact on traffic in that general area. So for the highway data, currently we primarily have you've seen it on Google Maps, colorful lines on the road. So we have that for speeds, and we have it for volumes right now. We're working on something that's a bit more accurate to actually represent congestion, because they definitely get a lot of that. And then we have a couple of charts like this. So basically, you get volumes and occupancy and speeds from each of the sensors. So if you look at the northbound versus southbound, you can kind of see a reverse diurnal distribution between the two. It looks almost like a mirror image, not quite. But again, red line's the mean, and then gray is basically the variation of speeds and volumes that you can see. So this is turned a little bit, so it's actually north, south, west, and east. But so basically, so those are corridor level visualizations for these two roads. On the x-axis, we spaced out the intersections to kind of represent how far away they are in real space. And then each color represents a turn direction, or like a travel direction on that intersection. So say north represents all traffic that comes into the intersection and goes north from there. And then the colors for north and south and for east and west are kept kind of similar. We actually changed the colors. In the next slide, you're going to see different colors. But that kind of represents the traffic flow through the corridor. And well, if you piece them together, kind of looks like that. So that rightmost or eastmost intersection on Shallowford is also where Gun Barrel splits off in both directions. There's way more going on south of Shallowford Road than north of Shallowford Road, so you can see that in these values being much higher than these values here. However, so we have all this traffic here, right? And it's getting more and more and more and more. And then there's all this shopping here. But it goes down to almost zero. So sometimes you can use visualization to debug your sensors because I don't think the cars went missing. They don't generally vanish into thin air. And I double and triple check. There's nowhere for them to go between those two intersections. So they just poof, are gone from the data. So that was definitely a good thing to look into, and there was definitely some kind of issue with the sensor at that time. It looks better for other time frames, but I figured I'll show this one because it's a good showcase for why visualization really matters and why it can be very helpful to the operators. We also have some fuel economy metrics. So these are for the entire region of Chattanooga and based on the RDS data that we have for the highways. So these are fuel economy metrics for highway traffic only in the general area. So it's fuel use and fuel cost for those two things. We're funded by DOE. They're interested in energy, so we're looking at energy. I think emissions are interesting too, but that's not what we're here for. So this is what we primarily focus on. So we have all these corridor level visualizations. We also have some visualizations on sensor level. So you can do boring things like lines. So we have a bunch of that. But we also can do something a little bit more fun. So we have these chord diagrams that basically show turn movements. I'm gonna actually try and, oh, that's not quite round. So it's usually round and I don't see my mouse, so that's not helpful. Okay, I guess I'm not demoing this, but I can show you on the slide. So basically, each of those arcs, which are those circle segments on the outside, represent the amount of vehicles that originate from that direction. And then the bands between them represent the traffic flow between the two directions. And then the color is determined by which direction we have more traffic flow in. And if you mouse over the arc, you're going to see how many vehicles come from there. If you mouse over a band, you see, like you can see at the bottom, 4,600 vehicles going from north to south, but only 2,700 going from south to north and 27 from north to south, so it's covered by south, because there's more going that way. Then we also have a bunch of incident visualizations. We have a heat map. We have incidents that are vehicle or non-vehicle incidents. We try to keep the colors kind of meaningful. It's not always possible, but everything that's fire-related is kind of reddish. Spills are, I think, gray. Flooding is blue. And then so that's for the bottom portion of these bar charts. And for the top portion, we're trying to keep with the same colors that we used on the map to represent those kinds of incidents. And then they're split up by time of day. So it's early morning, midday, afternoon, or like evening and night. We have heat map matrices, and then we also have another chord chart where you can see both time of day in the middle, type of incident, one ring out, and then weather impacts on the outermost ring. Also trying to stick with color schemes that kind of made sense for that data. And with that, I'm done. thank you for VTO for sponsoring this. Any questions?
Do we have any questions? I know I rushed her through that to make sure that we have an opportunity. What's Chattanooga going to do with all of it? Yeah, please.
I was just curious, the graphic you showed with the, basically the, like the cardinal directions and where cars are going, yeah, this one. How was that made?
So it's based on the data that we get from those GridSmart sensors. Or do you mean from a technical point of view?
No, more from like a graphical perspective.
Okay, so
Was there a specific program down?
D3JS has a chord library, or like the D3JS has a chord function. It's not super fun to use, to be quite honest, but I made it work. I really want to split up the bands so the color is split by how much traffic goes one direction versus the other direction, and that I couldn't make that work in the time that I had to make the chart, so it looks the way it looks.
Also on this chart, so if there's a road that's going northwest, do you have to pick which one to categorize it as north or west?
No, for this diagram, like if you have more directions than 4, that would not be an issue. But the sensor, at least in Chattanooga, there's no road that has such a sensor that has more than 4 directions, so I didn't have a chance to look at it. So for this type of chart, you can have any number of arc segments. So some of the examples that I saw had on the order of like 20 to 30 different like arc sections in there. So it's gonna get a little bit difficult to analyze if you have too many, but I think for intersections, I don't think I've seen one that had more than 6 roads leading into it.